Yeah, Miss, my name is Abdurrahman, and this is the explanation of lesson 7. I'm going to talk about the main concepts of this lesson, translations and transformations. And I'm also going to talk about the main types of functions, which are called parent functions. Now let's begin with the parent functions. There are four main parent functions. The constant function is the one I'm going to begin with. Constant function. It's a function where its equation is written in this way: y is equal a. I mean, y equals a. So y could be any value. Like y could be like maybe any value, maybe 2, maybe 3. And the graph of this function is that you pick the coordination of y and then you just a line that never stops. So the domain is all real numbers, while the range is just this value of a. The range of this function is just this value of a. And yeah, that's a constant function. Now to the identity function. Identity function, which is the parent of almost all linear functions. Identity function, and it's written in this way: function of x is equal to x. And mainly this is the parent function of the function of x is equal to mx plus b. So you graph it in the following. If let's say that y is equal to x, so if x is equal to 1, then y is equal to 1. Let's make a graph. x1, y1, so 1, 1, 2, 2, 3, 3, and then you go down, go down, go down, go down. That's mainly identity function. Now to the more complicated ones, the absolute value function. Absolute value function. So its equation, it has the absolute value sign, which means that if a number was negative, like let's say just to know what's an absolute value, if you put this sign and you put -6, which is a negative number, the absolute value of -6 is just 6. So just that's a side part, just to know what are like the sign of an absolute value. Now back to the function. So function of x is equal to absolute value of x. So the graph of this function is like a V, and that's the graph of this function. The domain is all real numbers, because as you can see, it includes all of the x values, and because of it includes all of the x values. The domain is all real numbers, and the range is above 0. So y is greater than or equal to 0, because only the values above more than or equal to 0 are included. Now to the last function that I'm going to explain. Parent function, I mean quadratic function. So it's a function in which function of x is equal to x squared, and the graph of this function, just if x is equal, if x is equal, for example, x is equal to 2, then y would equal to 4. So it goes up by the double. The value of y just doubles, not doubles, but it gets squared. So the y value is just a square. No, it's the what was it called? It's the x value multiplied by itself, just to be clear. So 2x 4y, so 2 1 2 3 4, so 2 4, and 1x would equal to 1y, so 1 1, and then 0 0, and then same thing on the other side. 2x would be 4y, and then 1 1, and this is how it's graphed. It's like a parabola, the y shape. Of course, it's like the original graph looks better, but this is hand drawn, so please let it pass. The domain, as you can see, is all real numbers again, and the range is y is greater than 0. So it's like the absolute value functions when it comes to the domain and range. Now let's talk about translations. Okay, I'm going to explain it in my way because the book seems like a bit complicated. So I'm going to use the same example the book gave. So g of x is equal to x plus 2 squared minus 4. Now we're not trying to solve the equation. We're just seeing how is this thing different from the main function, different from its parent function. Its parent function. So now I'm going to tell you something that you should memorize if you want this lesson to be easy. What's inside the bracket on the right side of the x is called h, and what's outside, this is called h, and what's outside, which is this thing, is called k. And it will come later, but it's not there now. What's on the left side is called a, and a is the slope. Like if a exists, we're going to take a as the slope instead of x. But now let's focus with the equation that we have here. Now we have that x plus 2 squared minus 4. So x plus 2 squared minus 4. So because this is not an absolute value function, we're gonna go, oh sorry, the original equation is that x is minus h. So when you apply the main equation to this one, it becomes minus 2. So we go to 2 units left, and 4 units down because it's negative 4. So, and 4 units down. Yeah, and you can look up the book to see the graph, but because it's going to take like some time for me to graph the thing on the iPad, and I don't want to take too long. Yeah, just because I don't want to make the listener bored. So you can identify a translation by looking to the main parent function. Like if you see an absolute value function, yeah, now I'm talking about the translations and how to identify them. If you see an absolute value function that begins here at this point, 2, 2, it has a normal slope. The slope is 1 on 1. This is the slope. So you know that the original function is function of x is equal to absolute value of x. So what you do is that you see how many units to the right it went, and then you put this number by negative, because we said that in absolute value functions, if there's a negative value inside, it will become positive. So the same here will apply. Function of x is equal to absolute value of x minus 2, and then how many units did go up? 2 units plus 2. And if the slope was like 2 over 1, we would put 2. So it would be function of x equals 2x minus 2 plus 2. But if the slope was 2, but it is not 2 in this case, so we're just going to put 1 on 1. So we're just going to leave it as x. Yeah, and that's how to identify translations from graphs. And the same thing applies to the other equation. Like let's say the quadratic function of x is equal to x squared. Yeah, if it was graphed like the same on the same location, but here it was a parabola instead of an absolute value, you just do the same thing, because in this, because the main equation is x minus h. So if h was a negative number, it would be positive, and if it was a positive number, it would be negative. So it kind of work, yeah, it works in it's the way it works is like similar to the absolute value function, but they're not the same thing because they're two different functions. Yeah, I kind of like it here. Now I'm going to talk about dilations. Dilations, horizontal and vertical, and they are included in the transformations overall. Now, to make it simple, I'm going to make like a table. A table. There are two types of dilations: vertical dilations and horizontal. Okay, you decide whether a dilation is vertical or horizontal when based on the type of the equation. If an equation is a f x, then it's a vertical, and when an equation is f a x, it's a horizontal. So how do you know if an equation is a f x or f a x? F a x, the slope is always with the equation. Like function of x is equal to absolute value 2x minus 2. This is an f(a)x because a, which is the slope, is inside the x. But an a(f)x would be function of x is equal to 2x plus 2 squared. That's an a(f)x, which is, this is vertical and that's horizontal. Now back to our table. A vertical, there are two types of vertical dilations. Yeah, you could stretch or compress. As I mentioned earlier, the type of equation is determined based, the types of dilations are determined based on the equation. So if the value of a, which is the slope, is higher than 1, if a is higher than 1, it's vertical. Now we're talking about vertical functions only. If the value of a is higher than 1, then it's a vertical stretch. If the value of a is greater than 0 but less than or equal to 1, then it compresses vertically. If the now let's talk about horizontal functions. f(a)x. If the value of a is greater than 1, it compresses horizontally. Compress. But if the value of a is less than 0 and greater than 0 and less than or equal to 1, then it stretches horizontally. This part is a bit complicated, but if you memorize the a(f)x and f(a)x, f(a), yeah, and this is the main difference between the vertical and horizontal dilations. How to know if a function is reflected or not, and also how to know if the function is reflected over the y-axis or x-axis. So function of x is equal to absolute value of x, negative absolute value of x plus 3 and plus 2, doesn't matter in this point. So if the x is inside the bracket, then it's reflected over the y-axis. But if the negative is outside of the bracket, then it's x-axis. So in this equation, function of x is equal to negative x plus 3. X plus 3, the absolute value of that, is reflected over the x-axis. And one additional tip: if there are no brackets in a function, then it is vertical automatically. Like you don't have to look in the f(a)x, the f(x), like f of x is equal to negative 2x plus 3. So you know that because it's vertical, the x, because it's the x is outside, the x is by itself, so it's reflected over the x-axis, and because a is the absolute value of a, like that's something that I forgot. You need to find the absolute value of a in order to know if it's vertically compressed, stretched, or horizontally compressed, stretched. So the absolute value of a is 2, which is greater than 1, because a is greater than 1, then it's vertically stretched, because as I said, this function is vertical, so it's vertically stretched. Yeah, and this was how to know if a function is reflected over the x or y axis. And if you want to know which type of function is in a graph, you just see if it's a v, absolute value. If it's a parabola, then it's a quadratic function, and if it's if it's like a straight line with only one y value, then it's a constant, and if it's an identity function, y will equal to x, so y is equal to x, which will just be a line. And this is how you identify the type of functions from a graph. And this was the explanation of the main concepts of this lesson. Hope you understood, and thank you. Have a good day.